Welcome to this explainer. We are surrounded by invisible forces every single day, right? But today, we're going to drag those unseen ripples right into the light. We are going to embark on an incredible journey from the absolute basics of how waves shape our reality, straight through to the highly dramatic, explosive climax of actually breaking the sound barrier itself. Let's get right into it. Because it begs this massive question, one that's totally obsessed engineers, pilots, and physicists for decades. What actually happens when you outrun the very sound you make? It sounds almost like science fiction, but it happens right above our heads. To really grasp this spectacular supersonic phenomenon and to understand the sheer brute force of it, we kind of have to lay down the foundational rules of motion first. So, Act 1, the invisible rules, the forces shaping reality. Okay, so here's the primary divide in physics. You've got mechanical waves on one side and electromagnetic waves on the other. Mechanical waves, like the sound vibrating through the air in your room right now or ripples on a pond, are totally bound to physical matter. They literally require a physical medium to push against. Without matter, they just cease to exist. But electromagnetic waves? They're the ultimate cosmic travelers. They move perfectly freely through the absolute void of space. That is exactly how the light from a distant star actually reaches your eyes without needing air or water to carry it. Which brings us to Act 2, the math of the matrix, or basically the cheat code of physics. And here is that cheat code. This elegant little formula acts as the core blueprint for understanding all wave movement across space and time. Lambda equals v times t. It perfectly connects a wave's length, its speed, and its period, or how often it cycles. And the crazy thing is, whether we're talking about a microscopic vibration or a massive, destructive seismic shift, this exact math governs the mechanics of that invisible force. It is the literal cheat code to reality. Moving into Act 3, the animal spectrum. Let's look at biology and the scale of sound. 20 hertz. It seems like just a number, but this represents a strict biological boundary for us. The lower absolute frequency limit of human hearing rests right here at exactly 20 hertz. If a vibration cycles fewer than 20 times a second, it's generally something our ears simply cannot register as sound. It is the absolute bottom floor of our sensory capabilities. In jumping all the way to the exact opposite end, our sensory capability absolutely maxes out at 20,000 hertz. When a mechanical wave vibrates faster than that, it completely vanishes from our perception. It's just pure silence to us, which, is exactly why you can blow a dog whistle and hear absolutely nothing, even if the air right next to your ears is vibrating wildly. So just outside our tiny window of perception lies this massive, completely hidden sonic world. Down on the low end, we have the infrasonic, under 20 hertz. This space is heavily utilized by huge animals. Think of rumbling elephants, whose deep calls can travel through the solid ground for miles without us ever hearing a thing. Then, up on the high end, the ultrasonic, over 20,000 hertz. That's the domain of shrieking bats, firing off rapid-fire sonic waves to hunt with pinpoint precision in the pitch-black sky. Biology has seamlessly adapted to exploit both of these extreme ends. And that takes us to Act 4, breaking the rules, the supersonic climax. We've seen how nature thrives within these frequencies, but what happens when those physical boundaries are pushed to their absolute breaking point? Well, as an object accelerates past the speed of its own waves, it creates what we call a bow wave, violently compressing the medium immediately ahead of it. Think of a speedboat tearing across a totally calm lake. When that boat moves faster than the water ripples it's generating, it pushes the water into a violent trailing V-shape. That is a bow wave. And the exact same fluid dynamics apply to the air when an object begins moving incredibly fast. Let's dive into the physics of that rapid buildup. Picture a jet accelerating until it hits the exact speed of sound. At this critical velocity, the sound waves it's producing can no longer escape out in front of it. They get trapped. Those wave fronts violently stack up, one on top of the other, merging into a singular, colossal wall of pressure right at the nose of the aircraft. And when that wall of compressed air finally shatters, we experience the spectacular, absolutely deafening boom of the supersonic shockwave. Fun fact, by the way, the crack of a bullwhip is actually a miniature sonic boom. All that trapped energy, those stacked mechanical waves we've been calculating this whole time, suddenly release in an explosive burst. It is honestly one of the most incredible, tangible physical demonstrations of crossing a velocity threshold anywhere in our universe. So it really leaves you wondering, if our entire reality is shaped by these invisible waves, what other extreme phenomena are hiding just beyond the limits of our perception? As we wrap up this explainer, I want to leave you with this thought. Physics isn't just about rigid equations sitting on a chalkboard. It's about the incredible reality of what happens when we test them, when we push past our biological limits, and when we literally shatter the sound barrier itself. Keep questioning the unseen forces around you, and I will see you in the next explainer.